The question is, there is a conductor of length L and a variable cross section as shown. The resistivity of the material is rho, whose radius of cross section is A on one side and B on the other side. How the resistance of the conductor between the ends depend on A and B. So, you are looking about this picture and whose length of the conductor is L. The radius of cross section on this side is A and on this side the radius of cross section is B. This is the given picture. Now, I am extending this picture in a different way to find the answer. So, what actually we have to find? We have to find the resistance. See, we have to find the resistance of the conductor, which is given here, right. So, resistance of the conductor we need. So, between the ends from here to here. So, we have to find the resistance of the conductor from end to end. So, how much resistance we are having between the ends and how actually it depends on the two terms A and B. This is to be found. Okay. So, for this I am having this picture. See this picture. In this picture what you are seeing, for the same conductor I had drawn many geometrical lines and I have chosen a small ring of element like this. So, this is nothing but this part what you are seeing. I magnified the same ring on in this picture, okay, whose width is right. So, width means this one from here to here. So, this is dx, right, this, and radius from here, right, here to here is the radius, and how much is the radius? Radius is r. Okay. So, the area of this conductor, this part of the conductor, which is A, which is equals how much? Pi r square. This is the area. And now we have to find this area, because I know the resistance of any conductor depends on the area of cross section. So, now we have to find some relation for this area. So, how to do that? So, I will show you. See this, here we are seeing a small triangular shape. Otherwise, we can call this line as a straight line. I mean this one. I simply try to draw that. Okay, see this. This is the line. Well, from here to here, I can draw one more line. Okay, so one more line I can draw here, this much. So, now this is our radius, sorry, what actually it is. So, that will be y, right, this is y, and how much is this distance? This is x, just refer this picture. So, here is x, right. So, the x is here and y is here, y is this one, and this is a straight line. How actually we express this? This is y is equals mx plus c. If we say this is the origin, so then c is equals 0, right. So, c is equals 0. If x is equals 0, then c is equals 0. So, x is equals 0 means c is equals 0. So, what I can write for this y is equals mx plus c? I can simply write y is equals mx, right. So, y is equals mx. So, now I have to express this y by using some replacement for this m. What actually that m is? M stands for the slope, right. So, this m is slope. How I can find the slope now? See the convention how I may use now. On this side this is b minus a, and on this side this is 0, right. So, y is equals 0 on this side at this point, and this point this is b minus a. Therefore, slope is m, which is equals delta y by delta x. So, what I can write for this? So, m is equals delta y is b minus a minus 0, that is b minus a, divided by delta x. So, the conductor extends from x is equals 0 to x is equals L, right. So here it is x is equals 0 and here so x is equals L. That means delta x is L. So this much is the slope value. So now what I can write for the equation y? This is b minus a divided by L, right, into x. So this is the expression for y. Now what I have to find? I have to find the radius of this circle. So now be careful because the radius extends from this line to this line. This is radius. Okay. So now radius is what? So radius is equal to, right. So this width is a. This is a. Okay. So a plus y. What I can write next, which is r is equals a plus what is y? Y is b minus a divided by L, right, into x. This is r. That means the radius of this element is found and it is little bit complicated, which is r is equals a plus b minus a by L into x. So this is the radius. Now I have to find the area. Okay, area. So how much will be the area? So area is nothing but what I can write. So for this area, I can write a is equals pi r square pi, and inside bracket what I can write? It is a plus b minus a divided by L into x, should be squared. So this much is the area of cross section of this element. Okay. So we found the area of cross section of this element. Now the resistance between the two surfaces of this conductor, that means this element. Okay. So resistance of this element is dr. Well, okay. So what I said, the resistance of this element is say dr. How actually we write the resistance? Resistance is always proportional to the length divided by area of cross section of the conductor. This is the expression or definition how we can use the mathematics for this resistance. So symbolically how I can write, this is dr, which is proportional to the length of that element is dx. Okay. So see this, the length of that element is dx, and how much is the area of cross section? The area of cross section is this much, which is a. Otherwise I can rewrite that later. Well, so further what I can do for this, you must know dr is equal to resistivity into dx divided by this a. Now I make every substitution for this. Okay. What I can do for this dr now? So dr is equals rho into, well, this is a dx in the numerator. In the denominator I should write pi, and inside bracket it is a plus b minus a divided by L into x. Don't forget to make it squared. This is the resistance of that element. Okay, only of a little thickness. Okay, so now for the full conductor, the complete conductor. Now for the complete conductor, what we have to do? Complete conductor. So r is equals, it is a integration of dr. So that is equals what I can write? It is rho divided by pi. Okay, so rho divided by pi, and I can remove this L square also. So that L square comes in the numerator, and the things which are left inside bracket is dx divided by, right. So this is a into L plus b minus a into x. It should be squared, and now I have to put the symbol of integration where x is the variable. So x varies from, so you must know this one. So x varies from 0 to L. Okay. So x is 0 on one side and x is equals to L on the other side. That means the length of the conductor. Now, what happens to this? So, I should put the limit x is equals 0 to L. So, now be careful about the denominator, which is something like this. So, for you should note any integration in the form dx divided by c plus dx, I mean d into x, be careful, you may confuse with this one, say some e into x. This will be is equals minus 1 divided by, right, e into c plus ex plus c. This C stands for some constant. Usually we forget it here because when x is equal to something, initial value, the whole thing becomes, that means the beginning constant becomes 0. Okay, so that is I am not going to express here. So that means in our notation, what actually this C stands for? This C stands for AL, right? E stands for B minus A. So now I have to rewrite this equation in a different way. That means by using the values what I already know, that is R is equals pi, I mean rho L square divided by pi, and what should be the result of this integration? It is minus 1 divided by, it is E is B minus A, right, B minus A, and inside bracket what I must write? It is C plus Ex here, that means which is A into L plus B minus A into X. Okay, all these things, and don't forget that we are having the limits x varies from 0 to L. So when you solve this one, definitely will get R is equals, that you have to solve. So definitely will get rho, right, into L divided by pi AB. This will be the result of this integration. That means the resistance of the conductor as they have shown in this picture, right. So the resistance of this conductor, what they have shown here, the resistance between the ends, okay, the resistance between the ends will be pi L, I mean rho L divided by pi AB. Okay, so this is the result. From this, what I can write? R is inversely related to the product AB. Okay, so this is what they are asking in the question, right? How the resistance of the conductor between the ends depends on A and B. Here is the answer, right? So R is inversely proportional to the terms AB.